So we're going to start today talking about multi-step conversions using dimensional analysis. But just to remind you about what we did in the last class period, here's an example of a one-step conversion. So the question says, calculate the amount of US dollar conversion if you purchase this tennis ball size strawberry, that's a big strawberry, in Japan for 500,000 yen. Okay, so it's asking you, I want to know how much this costs in dollars. This cost in Japanese yen, it costs 500,000. That is our given. 500,000 yen is what is given to us. What we want to know is how much does it cost in dollars? And how do we get there? We use our conversion factor. We know that every $1 is equal to 111.17 Japanese yen. Okay, so that's going to be our conversion ratio. So the first thing we're going to do is we're going to write down our given and put it over 1. Put over 1 to remind you that we're multiplying fractions. Okay? Then we're going to use our ratio to convert to dollars. So we have this ratio. We know every $1 is equal to 111.17 yen. So we can make this into a fraction. Well, we want the yen to cancel out. So we're going to put this on the bottom. And we're going to put the dollar on the top. Yen on the bottom, so they cancel out. So if we use the yen part, we have to use the other part as well. That will go on the top, $1. You enter that into your calculator, and you get 4,497.62 yen. I mean, dollars. Okay. Now, because this is money, it's appropriate to have to do 2 decimal places. But let's pretend it's not money. Okay, let's pretend it's not money. If it wasn't money, well, then we would have to go by our significant figures. Here, because there's a decimal right there. Here, this is 6 significant figures. Here, this is 5, so it should be 5. But because it's money, it is appropriate to have 2 decimal places. So we're going to start doing multi-step conversions. And I showed you this yesterday, but we're actually going to do it today. But you know how to do it already because you can do 1-step, and 2-step is not much more difficult. Okay, so let's look at this problem. It's already solved for you. But the question is, how many seconds are in one day? How many seconds are in a day? Well, I personally don't know how many seconds are in a day. I don't know offhand, but I can convert there because I know other things about time. I know that one day contains 24 hours. I know that 1 hour contains 60 minutes. And I know that 1 minute contains 60 seconds. So I can use these 3 ratios to get me where I need to be. So if I were to solve this problem, the first thing I would do is I'd write my given, as we did here. Given is 1 day. What we want is seconds, and these are our ratios. So we're going to go 1 day, and we're going to put it over 1. We want days to go away, to cancel out. So we need to look for the relationship that has days in it. Oh, wait, this one. This one has days in it. This is the relationship we can use to get days to cancel out. So we'll use this ratio. 1 day is equal to 24 hours. We want days to cancel out, so we will put this number on the bottom and this number on the top. So when you do that, our days cancel out. But now we're in hours. Do we have a relationship that has hours in it? Oh, we have this one. 1 hour is equal to 60 minutes. We're going to put the 1 hour on the bottom so that the hours cancel out, and then we'll put the 60 minutes on the top. Our hours have canceled out. Now we have minutes. Okay, and now we've got one more relationship that's got minutes in it. We'll put the minute on the bottom, the seconds on the top, and now when we look at our units, days have canceled out, hours have canceled out, minutes have canceled out. The only thing left is seconds. So now we just enter this into our calculator. Remember, we're multiplying fractions. Everything on top divided by everything multiplied on the bottom, and this is what you get. Okay, so we're gonna be doing problems like this. You want to make sure your units can cancel out diagonally. So if we go back here, see how this is diagonal? They cancel out diagonally, diagonally, diagonally. We want to make sure our units can cancel out diagonally, and all units should cancel out except for the unit you're solving. The thing that you're trying to get, the thing you're trying to get should not cancel out. And it should usually be in this position right here. We want seconds to be what we're left with, because that's what I want. Everything else canceled out. Okay. If it helps you, and you should do this, you can change any combination unit into a ratio. So in other words, if you have a unit like 0.05 milliliters per second, change it into a ratio. So then you know how to put it into a fraction. So any combination unit, a unit that's got a top and a bottom. Okay, just to show you again what we're going to be doing when we do a multi-step dimensional analysis problem. When we get to the stoichiometry unit, it will look like this. You're given 5 grams of magnesium. You want to know how many grams of magnesium oxide you can make. The same example I showed in the last class period. These are your ratios, and you end up using them one at a time. And you get something that looks like this. This is what we're building towards. We're building towards doing things for chemical equations. Okay? Building things, we're doing things for chemical equations. Okay, so let's do a problem here. It says, if a car is traveling at a constant speed of 55 miles per hour, how many minutes will it take to travel 19 miles? Our given is 19 miles. What do we want? Minutes. What do we have? We have a compound unit here, a compound unit. We have 55 miles per hour. So let's write that as a ratio, 55 miles per hour. So we can make a fraction out of these. But we're not trying to get to hours. We need something with minutes. Do we know how to go? Do we know how many minutes are here? Well, we can do a conversion between hours and minutes. So we have another ratio. We have 60 minutes to 1 hour. Okay, so if we're going to build a road map, we're going to go from miles, then we're going to go to hours, then we're going to go to minutes. Okay, so start with given, like we did yesterday. 19 miles, put it over 1. We want miles to cancel out. The only thing we have that has miles in our ratios is this guy right up here. So we're going to put the miles part, the 55 miles, on the bottom, and we're going to put the 1 hour on top. Okay, so now when we do that, miles cancel out. And we're left with hours. But we don't want hours, we want minutes. Well, that's all right, because we can go from hours to minutes. That's pretty easy. We know that 1 hour is equal to 60 minutes. So we can put the hour here, so that it cancels out with this hour, and the 60 minutes on top. We enter this into our calculator. 19 divided by 1 times 1 divided by 55 times 60 divided by 1. Or 19 times 1 times 60 divided by parenthesis 1 times 55 times 1, close parenthesis. And you get this number in minutes. Now we have to look at our sig figs. 2 sig figs right here. Our answer must be 2 sig figs. Okay, let's try another one. Pure gold has a density of 19.3 grams per centimeter cubed. Okay, look that's got 2 units. That's going to be one of your ratios at least. Determine the volume of a gold bar. Volume means centimeter cube is a volume. Determine the volume of a gold bar that has a mass of 12.4 kilograms. 12.4 kilograms. So what's given to us is 12.4 kilograms. What do we want? We want volume. So in other words, we want centimeter cubed. Excuse me. we have any ratios? Well, we have 19.3 grams per centimeter cubed. And here, we started with kilograms. Do we have any weight? We don't have anything with kilograms here. But that's all right. We have something with grams. And we know how to go from kilograms to grams. So let's put another ratio in. 1,000 grams is equal to a kilogram. Okay, so now we can solve our problem. Start with the given. 12.4 kilograms. Let's put that over 1. We want kilograms to cancel out. Well, we've got kilograms right here. We can use this ratio. Put kilograms on the bottom. We put grams on the top. Okay, so now our kilograms have canceled out. We're left with grams. Do we have anything that has grams and volume in it? Yes, we do. We have the first ratio. So we're going to put 19.3 grams on the bottom and 1 centimeter cubed on the top. We're left with units of centimeter cubed. We enter this into our calculator, and we get this number. But we need to look at our significant figures. We have 3. Make sure you can enter these into your calculator. So right now, pause the video and enter this into your calculator and see if you get this value. Okay, let's do another problem. So it says, use the back of a periodic table, which you guys don't have right now, to convert pressure from pascals to atmospheres. Pascals to atmospheres. So you don't have that, but you do have a conversion table, which I put in Teams. Let's say you don't have it. I'm going to give you that information in this problem. Okay. We're given 2.05 times 10 to the 6 pascals. These are pressure. Okay. We want atmosphere. That's another unit of pressure. So what ratios do we have? Well, if you look at your back of a periodic table, well, you don't have that, but I'm telling you, you know that 1 atmosphere is equal to 760 millimeters of mercury. That's also called a torr. But 1 atmosphere is also equal to 101.3 kilopascals. 1 atmosphere is equal to 101.3 kilopascals. Okay, but we don't have kilopascals in this problem anywhere. What do we have? We have pascals. But that's all right. We can go from pascals to kilopascals because we know what the metric prefixes mean. We know their value. Well, we know that 1,000 pascals is equal to 1 kilopascal, because kilo means 1,000. So if you replace this prefix with its meaning, you get 1 kilopascal is equal to 1,000 pascals. So let's do this problem. Let's start with what's given. 2.05 times 10 to the 6 pascals. Put that over 1. We want pascals to cancel out. Well, we can use this guy. Put the 1,000 pascals on the bottom, so that cancels out, and you're left with kilopascals on top. So pascals have canceled out. So now let's look at kilopascals. We have a relationship here. I said we have 101.3 kilopascals is equal to 1 atmosphere. Well, we're going to put this part on the bottom and this part on the top because we want kilopascals to cancel out. When you do that, your kilopascals cancel out and you're left with atmosphere. What do we want? Atmosphere. Oh, we're done. Now you must enter this into your calculator. 2 sig figs. There's your answer. You need to remember how to enter scientific notation into your calculator. So, okay, let's do a few more examples. Okay, so here, convert 0.115 kilometers to centimeters. You may move the decimal point as we learned in the last unit, or we can use dimensional analysis. I'm going to use dimensional analysis to solve this problem. Okay. The first thing you have to figure out is what is given to you, what do you want, and what is that ratio? What is that relationship between our given and our want? Okay, so given, easy, is 0.115 kilometers. Our want is centimeters. That's what we want. Do we know a relationship between kilometers and centimeters? You may not know that direct relationship. But what you do know is you know a relationship between kilometers and meters, and you know a relationship between meters and centimeters. So the meters is going to be your middleman. Okay, so you know 100 centimeters is equal to 1 meter. And you know that 1 kilometer is equal to 1,000 meters. These are the two relationships you know. When in doubt, head to that base. Okay, so now you've got two different relationships that each have meters. So that's going to be our middleman. So we're going to solve this problem like we've done every other problem. We're going to start by writing the given and stick it over 1 to remind you that these are fractions. Okay, so we've got right now our unit is kilometers, but we don't want kilometers. We're trying to get to centimeters. Out of the two ratios that we wrote, we only have one that has kilometers in it. That's this one. So that's the one we're going to have to use. We're going to want kilometers to cancel out. So we're going to put the kilometer part on the bottom. Well, since we used this, we have to use the other half of it. That's going to go in the numerator. So when you do that, now your kilometers have canceled out and you're left with meters. Do we want meters? No, we want centimeters. But that's all right. We've got a relationship between meters and centimeters, so we'll use that. So this is meters. We want meters to cancel out. So we're going to put this part on the bottom. And on the top, we'll go 100 centimeters. Okay. So when we look at this, our meters have canceled out. Our kilometers have canceled out. The only unit left is centimeters. Is that what we want? Yes. So we set up our problem correctly. So now it's a matter of entering it into our calculator. When you enter this into your calculator, you get 11,500 centimeters. Okay? You can put that in scientific notation. You can put it as 1.15 times 10 to the 4. You move that decimal 3 places. Remember, you need 3 significant figures. Their kilometers canceled out. Our meters canceled out. We're left with centimeters. That is our unit. Okay, let's do another problem. Convert 323 milliliters to cups. What is given? 323 milliliters. That's what we know. That's what's given. What do we want? We want to know how many cups that is. We're going from milliliters to cups. What ratios do we know? I'm going to give them to you because I don't expect you to know all of them. I do expect you to know this first one. We're in milliliters, so we're going to have to go to that base, which is liters. So we know that 1,000 milliliters equals 1 liter. That one you should know because you've memorized it. We also know that 1 liter is equal to 1.06 quarts. You may not know that. I'm telling you that one right now. Remember, we're trying to go to cups. Right now, we don't have any cups, but we know a liter into quarts. And then we also know that 1 quart is 4 cups. There we go. There we've got our cups, and we've got milliliters, and then we have a bunch of go-betweens. So let's start the problem. Write what's given, put it over 1. We have milliliters. We want to get rid of milliliters. We only have one ratio that has milliliters in it, and it's this one. So that's the one we're going to have to use. We're going to put 1,000 milliliters on the bottom, so it cancels with this milliliters. These milliliters cancel out, but we use this top part, or this part, so we must use this part as well. That's going to go on top, 1 liter. Okay, next. So now we got units of liters. We want to get rid of liters. Well, this is the only relationship we have with liters. We're going to put a liter on the bottom and quarts on the top, because that way our liters cancel out. Then we have this relationship. We'll put 1 quart down there, 4 cups on top. When we do this, our milliliters canceled out, our liters canceled out, our quarts cancel out. What unit are we left with? Cups. And that is what we're trying to find. Okay, so we enter this into our calculator, and we get 1.37 cups. We get 1.36052, but we need to go to 3 significant figures. So you have 1.37 Make sure you enter in your calculator and see if you can get that number. Okay, let's try one last one here. We're going to convert 7.005 feet to milliliters. As every problem, we're going to write our given, our want, and our ratios. Okay, so I'm giving you a bunch of conversions over here. We need to go from feet to millimeters. So let's figure out which conversion factors we're going to use. We've got millimeters, so let's try to get rid of millimeters. What do we have over here that has millimeters in it? The only one we have that has millimeters in it is this one. So that's going to be one of our conversions. So that's going to get us to meters. We're also trying to go for feet. Do we have anything here with feet? Oh, we've got 12 inches is equal to 1 foot. That's a conversion we can use. Okay. We also have 1 inch is equal to 2.54 centimeters. Those are all conversions we can use. So let's see which would make the most sense. Okay, we can say 1 inch is 2.54 centimeters. Okay, so that'll get us to at least the metric system. And we know how to go from millimeters to centimeters. We know that 1 foot is equal to 12 inches. That'll get rid of our inches. Here we got, but now we have feet. Oh, that's feet there, so we're good there. We just need to find that relationship between centimeters and millimeters. We know that 100 centimeters is 1 meter, and we know that 1 meter is 1,000 millimeters. Those are all the conversions we're going to use. Start with what's given, 7,005 feet. You want to get rid of feet, so which one are we going to use? This one. That's the only one that has feet here. Or you can look over here, it's the only one with feet. We do that, and our foot disappears. There's foot on the bottom, 12 inches on top. Our feet cancel out, we're left with inches. Now we need to get rid of inches. What do we have that has inches? Here, 1 inch is equal to 2.54 centimeters. We want to use this guy with inches as opposed to one of these. So it's 36 inches to a yard. Because this gets us into the metric system. And we need to be in the metric system because millimeters is the metric system. So we're going to put 1 inch on the bottom, 1 inch. So this must be on the top, 2.54 centimeters. Now our inches are gone. So now we're in centimeters. But we don't want centimeters. We're trying to get to millimeters. So if you don't know the direct relationship between centimeters and millimeters, that's all right. We can go through a middleman, meters. You want centimeters to go away? We use 100 centimeters on the bottom, 1 meter on the top. Our centimeters cancel out. What's left? Meters. We want to go meters to millimeters, so we'll use this guy. We'll put 1 meter on the bottom, and we'll put 1,000 millimeters on the top. Okay, so let's double check our units. Feet canceled out. Inches canceled out. Centimeters canceled out. Meters canceled out. What's left? Millimeters. What do we want? Millimeters. All right, we've set it up correctly, so we can now enter it into our calculator. You enter this into your calculator, and you get 2,135 millimeters. 4 significant figures. 4 significant figures. Okay, now let's do one last one. How many seconds are in 2 years? We want to go from 2 years to, we want to know how many seconds are in 2 years. Do you know how many seconds are in 1 year? I don't. So I can't do that directly in one step. I'm going to have to do several steps. So we're going to have to take this in multiple steps. So let's start off with how we started everything else. Let's write down what we know, what we want, and the ratios that we can use to get there. Okay, what do we know? We know we're given 2 years. What do we want? We don't want to know how many seconds 2 years is. Okay, so what are the ratios? We need to somehow go from years to seconds. And since we don't know directly how many seconds are in a year, we're going to have to kind of break it down. So we know that 1 year has 25.25 days. Okay? So if we do that, we'll end up getting rid of years and we'll end up in days. Do we know how many seconds are in a day? I don't. So let's break this down a little more. We know that one day is 24 hours. So that gets rid of our days and puts us in hours. Do we know how many seconds are in an hour? Probably not. So let's break it down a little bit more. Can we break down hours more? Well, we know that 1 hour is 60 minutes. And then we know that 1 minute is 60 seconds. So we're going to have to do these 4 steps to go from 2 years to 60 to seconds. So let's do it by what we know first. 2 years. Put it over 1. Okay, we want years to go away. So we're going to use this relationship. We're going to put years on the bottom because we want to convert to days. And so our years here will cancel out. Okay, so we're now in days. So we're in days. We want days to go away, so we use this relationship. Because we don't want days, we want seconds. We're trying to head towards seconds. So we're going to put days on the bottom, so it cancels out with this days, and hours on the top. Now our days have canceled out. Oop, oop. We're left with hours. But do we want hours? No, we want seconds. So we're working our way there. Well, we know that 1 hour has 60 minutes. So we're going to put the hour on the bottom, so the hours cancel out, and we'll put 60 minutes on the top. Our hours have canceled out. But we don't want minutes, we want seconds. Oh, we have one more relationship. We know that 1 minute will go down here, is 60 seconds. Now it's a matter of entering this into your calculator. You can't really see the number here, but it is 6 times 10 to the 7. This is one significant figure, so your answer must be one significant figure. Okay, if you go through the PowerPoint, which is posted in Schoology, you will find lots of more practice problems here in this PowerPoint. You should go through them. Okay, so this is where we're going to end today. And you will have some practice assignments right now.